The overall goal of the following experiment is to obtain maximum compliance in rodent test subjects to exercise on a running treadmill without the use of any form of negative reinforcement. This is achieved by first obtaining baseline measurements of the parameters that are intended to be evaluated, in this case, locomotor activity in an open field, following the implementation of an exercise regimen. As a second step, the rodents are acclimated to obtain maximum compliance to the exercise regimen. This includes familiarity with the treadmill environment, learning to run on a slow-moving treadmill, and ensuring that a backstop is in place on the treadmill lanes so the test subjects are always segregated from deactivated shock coils. Next, the exercise regimen is employed for 12 consecutive days at 30 minutes per day. The non-exercised group sits on a stationary treadmill for the same duration. The results show this exercise regimen produces a significant difference in weight loss of rats as compared to their non-exercised counterparts, demonstrating its use to independently evaluate exercise impact upon measures previously determined at baseline.
The main advantage of this technique over existing methods is that maximum compliance to forced treadmill exercise can be obtained in rodent test subjects, and in particular aged rodents, without the use of any form of negative reinforcement.
In order to best understand the neurobiological impact of exercise on CNS function, it is important to match the duration, frequency, and intensity of exercise with behavioral and neurobiological outcomes. It is the goal of this protocol to help investigators achieve these aims.